congratulate His Highness Sheikh Mohammed bin Zayed bin Rashid Al Maktoum, ruler of the Emirate of Dubai, and His Excellency Dr. Saeed Mohammed Al Tayer, CEO of DIWA, on this great organized event and all of the achievements they continue to bring to Dubai and the UAE. I'm pleased to be here and thankful that the committee selected me to talk about this life-changing event of energy and sustainability. Today there's going to be a lot of technical information, so if you guys have questions, I would be more than happy to answer them. So a little bit of information about me. I'm an architectural engineer by profession, but now I'm currently working as a business development manager for AEC. I have studied in the US, worked in energy modeling for a very long time. I know I might look young, but I'm actually old. So before speaking about this topic, they say that public speaking is the #1 fear for some people, and they say that death comes second. That's quite ironic because I'm scared to death right now. They also say that, you know, you're giving a successful speech if you have the people at the edge of their seats. So I hope to see many people falling because that would give me great comfort. Okay, with no further ado, we're going to get into the topic. So I know that this is a mouthful, topic, which is revolutionizing sustainability. What does that mean? And what does the BIM mean? And what does energy modeling mean? So we're going to address all of these things later on. So just as a statement, and I want you to keep that in your mind so when we go on you can understand exactly how we do things. Us as a company, we successfully integrated the programming, linking the newest softwares and technologies that are already available in the market together to bring you this product that's quite new and also comprehensive of everything. So what is BIM? What does BIM mean? And what is 3D energy modeling? So basically BIM means building information modeling. And that means it's the creation of a management of a digitalized tool. You get to see everything in front of you in 3D of a building or a structure. So you are basically putting every element, structural, architectural, MAP, all of these elements in order for you to get to see all of that in 3D, not just in a 2D view. Okay. How that's important? It's important because for engineers and for people who are designing things, they can get to see everything that they are creating right in front of them and how it impacts the final design. Okay? It's not all in their imagination. You can actually see it. What is now 3D energy modeling? So before I talk about 3D energy modeling, I would like to talk about sustainability and energy saving. This topic is very, very important for sustainability and energy saving because 3D energy modeling really helps buildings save anywhere from 12% all the way up to 70% on some buildings. If you utilize some of the new innovations that are in market now, like solar PV panels and the conservation of rainwater, waste management, all of those things, you can basically save a lot more to that. You can basically use a zero energy for a building. So, and that's crazy because if you think about it, that is the future. That should be the future for a lot of our cities and our governments. So energy modeling is a virtual computerized simulation of a building or a structure. So basically you do a simulation for the building to see how you're saving energy, whether that's from HVAC design or MAP design, HVAC design, lighting, the cooling and the heating of the building itself, the architectural materials, all of that. What things can energy modeling do for you, for your building, whether it's existing or new? You can predict the monthly energy consumption for the bill. You can predict your DIWA bill, basically, pretty much. You can predict the U value and the R value for engineers who are here. You can basically predict the annual energy cost, CO2 emissions. You can compare different materials together, compare and contract different options that you can do for your design and which one saves energy the most. You can analyze different technological ways to save energy, something that's new, like solar power. Determining the energy needed to operate a building. So how much energy do you need to operate your building? So you don't over-design and end up using a lot more energy than you need. Later on, you can also predict the points of losses, where you're losing energy. And I will show you all of that later on. You can also provide an energy chart with a rating. So for every building, okay, you can predict a specific rating that comes with that building to identify whether this building is energy efficient or not energy efficient. So how do we create a 3D energy model? Okay, so first, for all of the people who have worked with engineers before, there's a lot of 2D drawings that gets developed. Architectural drawings, MEP drawings, structural drawings, geotechnical drawings. We take all of that, all of those designs, and we basically make a BIM model, a building information model that is in 3D. After that, we make a 3D printable model in order for us to see where you are losing energy. An example of that is if you have two walls, the two walls are not connected properly, this space between these two walls is considered an energy loss. You're losing energy, leaking energy out of that location. Okay. Also, after that's done, we determine the energy zones and then start making the energy model. There is about 57, I believe, energy softwares that are available in the market. Each one has a specific function. Some program gives you the simulation for how the sun can help you, how solar energy can help you with the energy consumption. There is simulations done for HVAC, simulations done for ventilation, simulations done for lighting. There's a lot of different softwares, each one has a different function. So what we do is we combine all of these softwares together using a programming analysis tool that we have developed for our company to give you a one comprehensive final result for that building, to understand everything and how you can save energy from all of the parameters that you put inside of your design. After that, we obtain the results and we obtain multiple simulations that we can give to people if they would like to understand it further, and that is accompanied with charts and actual results. So here is an example of an actual project that we did in Dubai. This is the Dubai Sport City Leisure Club, and what we did, like I said, here's the process. The first thing is that we took a 2D design of architectural MEP and all of those elements, and we made out of that an actual BIM model that you can see, that you can identify each single element, or whether it's architecturally, structurally, mechanical or electrical inside that. So we can see it better, and you can identify every element that you're creating in front of you in 3D. After that, we have created the 3D BIM model. So the 3D BIM model, like I mentioned before, it helps you identify where you are losing energy, because it's basically a smaller model that you are creating out of something that's going to happen in reality. Okay? After that, we create the actual 3D energy modeling using all of the different softwares. So basically here, what you see in front of you in red is the building as we get it. Okay, we get it using a lot of the parameters that come already with the building, and it comes in red. Red means it's least efficient. It uses the most amount of energy. And what we try to do is implement some changes, do a lot of different changes architecturally, structurally, whichever ones that are easy to make first, and we try to turn that building to a green building. Okay, so that's what you see in front of you. Some of the studies that we do to help us get to that point is a system feasibility study, gas emission study, cumulative financial cost study, which is very important for people who want to know how much money you're saving in that building. Natural resources use, how much of natural resources you're actually using versus resources that are not natural, things that you have to pay for. Energy efficiency study, sustainability study, and new innovation study. Here are some of the parameters that we use inside our design. There is about 3,000 to 16,000 different parameters that we can put inside the building. The building, it depends on what kind of building it is, or if you're doing a bridge, is different than doing a 3D energy study for a hospital or a really big high-rise. The parameters change. But some of the parameters include these things, like outside temperature, inside temperature, glazing that comes with the building, the U value for the building, the roof materials. If you're using, for example, the materials, if you're using steel versus concrete, because concrete saves energy. We do things like identifying thermal bridges, infiltration, light power, the AHU, the ELV rooms consumption inside the building. All of these different parameters, they go on and on and on. We take everything that is available and we put it into basically get a very accurate energy model. After that, we don't also take just these parameters. We look at the architectural parameters. We look at the massing. We look at the envelope of the building. We look at the loads. How many people is going to occupy that building? Basically, we look at the schedules of different things, like how much lighting you want in that building. Does the owner want the lighting to be LED versus regular lighting? Things like that. All of those are different parameters that we take into account. And then after that, we get, like I said, the building as is, okay, and we try to develop new innovations to make it a green building. Later on, the types of charts that you get, this is an example of a chart. It basically gives you an exact number of how much you're using in kilowattage, okay? And what is the temperature, and what is the areas that you are consuming the most energy. You get that in the actual model. So if there is one area that's using a lot more energy than a different area, we study that to see why that is. And all the charts are accompanied with something like heat maps, energy consumption charts. It's actual numbers that you can control as an engineer. And with the calculations, if you change a few parameters, you make something great out of it. So this is basically the programming that we do. The programming is basically, we use a lot of different programs together. Programming languages like Python, like Java, like C++, to combine all of those programs together, which is currently, nobody really does that. Here, this is basically a chart that gives you the range of how much energy we were able to save for that particular project, Leisure Club. Just by the replacement of architectural materials, so changing the concrete, for example, changing the glazing, the shading, the architectural facade, you can save anywhere from 9 to 12% on consumption. Replacement of mechanical equipment, so if you replace the heating, ventilation, air conditioning systems, if you change the electrical equipment, if you change the plumbing equipment, some of these things can save you anywhere from 3 to 4 each. Okay? Value engineering the position of different equipment. So what that means is, if you have a specific equipment for cooling or heating that's in the corner, it consumes a lot more energy to get to the other side of the room that it's in. Versus if you have it in a centralized location, you can save a lot less energy. So basically, the energy modeling tells you the exact coordinates and where you need to have those equipments to save the most amount of energy. Also, the design for more energy efficiency, if we can do some things with the design to try to value engineer the energy consumption. Also, now we're going to get into the utilizing the new innovations and solar power. Some of the new innovations in solar design, photovoltaic, smart, natural, passive design, that can save anywhere from 5 to 6%. New innovations in conservation of rainfall water using weather-sensitive irrigation systems. Passive cooling by using thermal inertia. Heating water by solar collection. Harvesting natural resources like wind power, waste to power turbines. Surface radiant cooling, so basically putting radiant cooling material, having the water run inside the walls to cool your building. All of these things can save anywhere from 16 to 19%. So if you do the math, that can save anywhere from 39 to 51% of your energy consumption. And that's just, without doing a lot of work just by changing a few things to make your building more energy efficient. So, like I said, 39 to 51 at the end. Now, we're gonna look at where we are versus other places. So this is the US national average of the predicted energy use intensity. So you see that most of the numbers are around, 44. If we look at the map after that, 44 is very close to being energy efficient. And the ultimate goal for most people and for most countries is to get to net zero of energy. So they use zero amount of energy to operate a building. They use it all with natural resources instead of using a lot of energy that we can pay money for, basically. This is a map that is very, very important that I will get to talk about. In Africa, most places of Africa, Latin America, all of the places like that, you can see that the orange dots means the least efficient energy consumption. They use a lot of energy. Places like India, they use so much energy to the point that it's all just going to waste. If you look at Japan, if you look at China, if you look at Europe, they're all bright blue of the codes that they're implementing and things that they would like to do with sustainability and energy efficiency. If you see where Dubai is actually in the orange, and you have Masdar city is in the blue. It's a bright blue dot, okay? Which means that most of the buildings that they are doing, it's energy efficient, but it's not to where we want it to be, okay? So this is a statement that I would like to, the help of all of you guys is to hopefully in the future turn Dubai to a blue dot in an orange sea by using 3D energy modeling. So who can benefit from this service? Governments can benefit from this because it helps boost the economy and save resources. Engineers can benefit from this. They don't have to do giant spreadsheets and giant designs and over-designing and doing a lot of things that are not needed. Manufacturers can benefit from this. Building owners by saving money. Building tenants by saving money. The environment can really benefit from this because you're really helping the environment so it doesn't have a lot of things that might hurt it. So I would like to make a statement is that God gave us free will to basically take the resources that He gave us and use it in a good way. So we would like to use these resources to be more energy efficient rather than using it in our own destruction and hurting the environment. So the challenge is we would like I said, to help the Arab world and to help Dubai to be a more sustainable place. So if you guys have any questions, please go ahead and ask me, or you can visit me at the booth. Any questions? Mike? More? The map? Back again? Here?
Again, like 3 more slides back.
Here?
Again, please.
One more?
One more. This is Dynamo. I'm wondering about the software you are using for programming.
Yeah, like I mentioned, this is not one software. This is called a Python script. So
It's Python.
Yeah, so basically a Python
Language
script.
itself.
Yes, so we are using, like I said, there is about 57 softwares that do energy modeling, but they all have different elements that it does for you. So what you're doing is that you're combining all of these into a Python script, or we also developed our own programming that I'm not showing because it's not patented yet. So we develop our own programming to combine all of these together.
In-house.
In-house, yes. We are an architectural engineering firm. We also do all of that. So since we have all the programmers and the engineers all in-house, so we have different disciplines that we can combine, which is a blessing. So
I wanted to ask about in general for BIM, for energy modeling. I think that major problem we are facing when we are working with different consultants that this kind of energy software they are not authorized. I mean, when you make something for solar energy, I'm a solar thermal business development manager and certified trainer through Mina Abraham Metry at Berlin, Germany. And when we are going to make thermal analysis for such application, they tell us, okay, it's not mentioned in Ashri for example, we will not.
Yeah, I understand.
We don't trust this calculation.
Like I said, this is something very new. When you combine programming with engineering, most engineers, they just like to use the traditional ways of doing things.
Yes.
They don't want it to, so it's not implemented in the code. However, if you look at the ACI, or if you look at ASHTO, if you look at all of these new codes, they have a sustainability section that they are implementing all of these changes in. It's not yet there, which I agree with you, but hopefully in the future, I hope, as many companies do hope the same thing, that they will implement these changes. A great thing is that we advise building owners that they can implement these changes without having it authorized by a specific company, just to save the environment, because the design is still the same. It does not change anything in the loading requirements or what kind of building you need to make. Everything is still the same. You're just making it less or more efficient.
One more question. And for when we are going to use the main tool for them, most of the companies here or consultants, they are using Revit.
Yes, Revit.
Yes.
Revit is only a part of this, which is the second step that I talked about
Yes.
earlier, which is the BIM, which is making the building information modeling, which is only taking 2D into 3D. So that is this step here. That is actually using Revit. You are right.
Okay, but I mean the tool you are developing yourself. Is it also could be involved in Revit, or it's something in-house?
Yes, companies like Revit, they are trying to implement 3D energy modeling within Revit, but Revit is made for 3D visuals. It does not have the capability to understand programming, which is 3D energy modeling, and that's why it cannot be implemented inside of Revit. They can implement an outside source, which is something called, if you download an extension tool, but it's not within Revit itself, because Revit is made using different programming than programs like Rhino, like Energy Plus.
Okay.
Good. Any other questions, gentlemen?
Yes. Is this being benchmarked or encapsulated?
Oh,
Yes,
sorry.
I hear you. Yeah.
Okay.
So anyway, has this design has been encapsulated in things like the LEED program in America, the leadership in energy and environmental design, the green building?
Yes. So.
Or has it been added in the US in renewable portfolio? Or for example, in the US, there is the Salmon Group, they're the biggest operator of shopping malls in the US.
So you're comparing this to elsewhere. Yeah, exactly. So like I said, I'm from the US. I studied at MIT for school. And they do a lot in the US, they do a lot of research on these things currently. They have not gotten, or I can say they have not gotten to the software and the programming that we have done yet, or nothing that I have heard of, because everybody's just doing what they can look for. Like if they are doing simulation just for solar power, but they did not basically do a comprehensive design for everything. So basically, they have things like that in the US and they have implemented it, but just because something like this is so vast that not a lot of people actually, not a lot of people have the interest in something like this except the building owners and the engineers. And just because it involves so much technicals between the coordination between the MAP team, the architectural team, and the software industry, so it involves so many disciplines coming together, so it's hard. But we hope that this can get implemented in the future. We implemented that. I worked on something similar for the parcels A, B, and C for the sustainability district in EXPO that will eventually come to live in April of next year. We have also are trying to get this implemented with Sustainable City, in Sharjah Sustainable City. We have reached a lot of people that totally appreciate what we're doing. So hopefully this can be more readily available to the new market and to everyone soon. Any more questions? I think I saw somebody raise their hand and then maybe they got scared. All right, well, thank you guys very much for everything, and I'm happy to be here. Thank you.